Alright, in this video I'd like to go over the simple machines again and how it relates to mechanical advantage. So the first thing we're going to look at is the lever, which we've done before, but do it again. So with the lever, there are three types. The first class lever has the fulcrum in the middle, and then the two arms of the lever. We're going to push down on one side. That's going to be our input force, and the distance from the fulcrum to the point where we do the pushing is our input distance. Now, for example, if I pushed halfway down here, my distance wouldn't be the whole length of the lever here. It would just be the length to the force. So, for example, draw it this way. If I made the lever longer, my distance is to wherever I'm pushing on the lever. And then we also have our output. So say I had some box here that I wanted to lift. The distance to the object, that is our distance out. Obviously we want the object to move up when we're pushing down over here, but what we're having to overcome is the force out, which is going to be our gravity. Okay, for a second class lever, the fulcrum is going to be to the side. Our load will be in the middle. So this is like a wheelbarrow. So our distance from the fulcrum to the load, that is our distance out. And our force out is going to be gravity pulling that object down. And then our input distance is going to be, again, the distance from the fulcrum. I know my arrows aren't perfect here. The distance from the fulcrum to the distance where you're applying the force to lift it. And then finally, third class lever, things that we said like a broom, baseball bat, hockey stick, tennis racket, lacrosse stick. We have our fulcrum. Our force is going to be applied somewhere in between the fulcrum and our output. And again, our distance in is going to be here. I'm going to mark that over here, distance in. And our force out, we'll say it's, again, the random box at the end of our lever here. That's going to be our distance out. And for mechanical advantage on a lever, it's going to equal the force out divided by the force in, or mechanical advantage is equal to the distance in divided by the distance out. So if we look at all these examples, the distance in divided by the distance out, the distance in divided by the distance out, the distance in divided by the distance out would all give you mechanical advantage. And then the force out, the output force, mass times gravity on this object, times the force in, whatever you're doing to push the object, you divide those two, you'll end up with the same number as the distance out over the distance in. That would be the minimum amount of force required to just get things moving. Now, obviously, if you pushed harder, this thing's going to be moving faster, it's going to accelerate faster, forces would change, but we don't need to get into that. Typically what we're going to ask you is to find the mechanical advantage of the type of lever. It's just those base numbers, or like in homework question number 7, once you find the mechanical advantage, you can use that information to solve for one of the forces. Okay, next. We're going to go over pulleys. layer 2 does not want to work, so I'll try layer 3. Alright, pulleys. So we have a fixed pulley. Fixed pulley is, as its name says, fixed. So in this case, it'll be attached to the ceiling. And I have some object I want to lift. So I'm going to attach my rope to the object, bring it around the pulley, have it come down the other side, where I will be standing to pull that object up. Now, I'm going to have some output force. And I should do that in a different color here. Some output force. And the output distance is going to be however high I raise the box. Now, if I look at this rope, however far I pull this is going to be the same distance that this rope moves. And if the distance is the same, then my mechanical advantage equals the distance in divided by the distance out. No matter what those numbers are, if they're the same, my mechanical advantage is going to equal 1. So for a fixed pulley with just one pulley, my mechanical advantage is 1. Which means mechanical advantage equals the force out over the force in, which is also going to be equal 1. We already established that our mechanical advantage is 1. So whatever this force is the same force I need to pull with to get that object to move. Now, a simplified way of looking at mechanical advantage of pulleys is I just need to count the number of ropes that actually do the pulling. I shouldn't use purple, I already used that. It's green. The number of ropes that actually do the pulling. This rope here is the only one pulling the object up. This one just changes the direction. So next, let's look at a movable pulley. Alright, so I still have my ceiling here. I have my object resting on the ground, but this time I'm going to attach my pulley to the object. I'm going to anchor my rope onto the ceiling, bring it down under the pulley, and back up to where I am standing on some platform trying to lift my object. So I have my output force, it's the same output force as it was before. In this case, for my distance out, however far I raise this object, distance out, each of these ropes have to move that far. Okay, so in order to move the whole box with the pulley up some distance, say 1 meter, each of these ropes have to move up 1 meter. So in this case, each of these ropes are helping me pull the object upward. So in this case, my mechanical advantage equals my distance in, which is 2 times my distance out, divided by whatever my distance out was, right? Because my distance out's here. Each of these ropes have to move that distance, so 2 times distance out, which means I get a mechanical advantage of 2. So if I have a mechanical advantage of 2, 2 equals force out divided by force in. Therefore, my force in equals force out divided by 2. So the force I have to use to move this object is half the force of the object itself, on the object itself. Okay, and again, the other way to count this, remember I had one rope pulling up here, and I have a mechanical advantage of 1. Over here, I have 2 ropes pulling up, and I have a mechanical advantage of 2. So 2 ropes gives me a mechanical advantage of 2. All right, next we're going to stick with pulleys, but now I'm going to do a combination pulley. Layer 4, there we go, okay. So I'm going to draw this one 2 ways here. I have the pulley attached to my object, and I have a pulley attached to the ceiling. So I have a movable pulley and a fixed pulley, and I have 2 different ways I can run my rope. The first one, I can have it attached to the fixed pulley, run it around the movable pulley, back over the wheel of the fixed pulley, and down where I am to pull it. The other way, I could attach it to the fixed pulley, have it go over the movable pulley, have it go over the fixed pulley, under the movable pulley, and back up, where I am standing to help lift my object. Alright, so in this first one, this first combination pulley, I have 2 ropes helping pull up. This one just changes directions. It's not pulling the object up. In this case, I have 3 helping to pull the object up. So my mechanical advantage in this first example is going to equal 2. And my mechanical advantage in this second example equals 3. Alright, and the way I can figure that out, again, I can look at the distance. So every 1 unit of distance I move this up. Let's call it 1 meter. I want to raise this 1 meter. Each of these ropes needs to go up 1 meter. So this equals my distance out. And these equal my distance in. Those together, adding those 2. If I look over here, I do the same thing. If I want to go up 1 meter, that would be my distance out. Each of these ropes needs to move 1 meter in order to get the whole contraption to move 1 meter. So my distance in equals 3 meters. Mechanical advantage, distance in divided by distance out, gives me my 3. Okay, so those are the first 3 types of simple machines. For the next, the ramp, looks like my 15 minutes is almost up. I'm not going to start on ramp on this video. I'll have to start another video. And that one I'll go over ramps, and then I'll mention screws, wedges, and wheel and axle. And we'll be back in a minute.